Greetings, grade 9s. Welcome to this Worksheet Cloud grade 9 maths lesson where we take a look at the basics of algebra. I'm Mr. T, your maths teacher for today. I enjoy maths, but not everyone does. Worksheet Cloud is all about having fun while you learn. And with that in mind, they have instituted a rewards hub on their webpage where you can earn rewards while you learn. Sorry, Adrian, is this correct? You're telling me that we're giving them rewards for doing something that's good for them and that they should be doing anyway? He's nodding. Apparently that's what we're doing. So that's pretty cool for you. You can get rewards such as fresh merchandise from Worksheet Cloud, Nomu hot chocolate to sweeten up those study breaks, and possibly even get a chance to win a PlayStation 5, which would be a pretty cool reward for after you're done with your studies. More about that later. Let's get back to the maths for today. Right, so we are looking at the basics of algebra. We are looking over the next couple of lessons or during this term at some of the factorizing you can do with algebra. And if you're going to get that right, you really have to have an understanding of the basics of algebra. Otherwise, you're on shaky ground when it comes to working these things out. So for some of you, this may be like, oh yeah, we know how to do this, but it really is important that you have this in place because pretty much from last year and this year, you're reaching a point in your maths career where we've been building up the basics, and now we rely on the fact that you know those basics in order to do the things that you have to do. And if those basics are not in place, it does make the maths pretty tough. And I don't want you to find maths tough. I want you to enjoy it. I want you to be going, yay, it's maths lesson. I know that's maybe unlikely for some of you, but there are some things in life about which you have a choice. Most of you probably don't have a choice about taking maths. In some form or another, you are going to be taking maths between now and the end of your school career. Probably. Some of you, maybe not. So if you don't have a choice about that, what you do have a choice about is how you're going to approach it and how you're going to deal with it. So you can put your best in and do your best and approach it with a positive attitude. And that'll be the best way you can have it and probably enjoy it more than if you walk into every class going, I don't want to do this. I hate maths. Because then you're just choosing to be miserable every maths lesson between now and the end of your maths learning. So make the right choice on that. Approach it with a positive attitude. My goals for this lesson: know the main terminology associated with algebra, be certain of what terms are, be able to identify what terms can be added and subtracted, be able to multiply terms and divide terms with exponents, understand some of the shortcuts we use in maths, and then just, some of the basics. What do we do with an expression? What do we do with an equation? What is the difference between an expression and an equation? So those are the kinds of things I'm hoping you take away from this lesson. Right, expressions and equations. I think often the teachers don't make it explicit what the difference is. I think it's actually kind of written over here. The first part of the word equation sounds like equal, and that's like a dead giveaway. It has an equal sign in it, but I'm going to look at an expression first. So the expression has no equals. When we are looking at expressions, the variables like x or y, they don't have a specific value. So we don't know what they are. It's like a formula for getting an answer. So let's say you are wanting to go kayaking, and the person who is running the kayak business says, okay, it's 100 Rand an hour. Now, for you to know how much you are going to pay, then you just say, okay, well, X is like 100, so it's 100 Rand an hour, and I'm going for 3 hours, so 3 times 100, that'll be what I'm going to get from that. An expression like this, maybe the kayak operator says, okay, we do it that way, it's 100 Rand an hour, but you also then pay a fixed 50 Rand whether you go for half an hour, 3 hours, whatever. So then you'd have 3x plus 50. If you're going for 3 hours, you just change the number of hours each time. But you could also then, in fact, I'm doing it the wrong way around. We would rather then say x is the number of hours. We'd then say it's like 150 or 100 Rand an hour times however many hours you have. So you have like 8 hours, then that's a long kayak. But 100 Rand times 8 plus the fixed rate. So that's the kind of places where we use expressions. There is no specific value. We will plug in the value depending on what we're working with. Now, what you're expected to do with expressions is not to solve it, because you can't solve it. You're expected to simplify it, expand it, or factorize it, depending on what it is. But you can't solve an expression because there is no actual answer to the value of the variable. An equation has an equal sign. I mean, if you take nothing else away, if it's got an equal sign, it's going to be an equation. If it doesn't have, then it's an expression. Variables do have a specific value. There's often only one value that this could be. There are times when it could be any number of values, but in this, those are specific cases. But in this kind of thing, x has a specific value. So I've given you the example 3x plus 4. X can only be 2 because 3 times 2 is 6 plus 4 is 10. You can't find another value that would make this equation true. So the variable has a specific value. And in working these out, you have to find out what the variable is equal to. So you'd have to solve for x or solve for y or whatever the variable is. Okay, it's expressions and equations. Terms. Terms are separated by plus and minus signs. They are not separated by multiplication or division signs, only plus or minus. So in 4x minus 7, also note that the sign belongs to the term. So the sign that comes in the front of it is part of the term. So in 4x plus 7y, the term 4x, which is actually plus 4x, and minus 7y. So the term includes the sign that goes with it. I've put this with the plus. This is like one of the occasions where mathematicians are, I always say, lazy to make my classes prick up their ears and pay attention. They're like, what, maths people are lazy? But actually, it's really just about efficiency. You've been using this your entire life. You don't go around telling people that I'm plus 13 or plus 14. So because positive numbers or positive integers are used more frequently than negative, maths people will just agree, okay, well, if it's positive, we won't put anything there. So if you don't see anything, it's positive. And we'll indicate if it's negative. And that's why we put the negative sign in front. But we don't normally, if it's the lead or if it's on its own, put a plus sign in front of it. A couple of other things which you should by now know. The whole number that goes in a term with a variable is called the coefficient. If a whole number stands on its own, it's called a constant. Constant meaning unchanging, and that's because, for example, on our previous slide where we said 3x plus 4, that constant doesn't change. It can only be 4. Right, so terms are separated by that, and sometimes in grade 8 or earlier you might have been asked to say how many terms are there, that sort of thing. Okay, laziness of mathematicians. I started explaining that, why we don't put the plus in front of it. We also, if we're talking about age, we don't say, oh, I'm 013 or 014. It is true that you have 0 hundreds in your age, but can you imagine then if you also put in, oh, I've got 0 thousands in my age, 0 10,000s, and where do we stop? So yeah, it's an efficient thing. We just leave it out. We don't waste our pencils and pens by writing things that are unnecessary. So in algebra, when you're thinking about it, we say 3 times 3, but then we're like, instead of a times, let's put a dot. So this means 3 times x equals 3 and that means times, so 3 times x. And then we're like, just, okay, if we put them next to each other, it just means it's 3x, 3 times x. So we kind of just condensing things to make it simpler, make it easier, make it quicker to write. We don't do it between numbers. Like if you had 3 times 6, you wouldn't say 3.6 because then it might be confusing. You might think, oh, well, 3.6 means 3,6. And you wouldn't just put it together because then it wouldn't look like 3 times 6. It would look like 36. So we only use it with that with algebra. Okay, when adding and subtracting terms, it's pretty simple if you just remember that everything about, well, the variables in the terms, including the powers, have to be the same. So it has to have the same letters, it has to have the same powers, otherwise we can't add it or subtract it. So for example, if you've got 4x cubed plus 5x, that is already simplified. You can't simplify it further. And to show you why, I used an example here. So if we tried to make it this, add our 2 coefficients and make that 9, and then add our powers, we'll make, okay, so that'll be x to the 5. So this would be 9x to 5. If we did that, then we're saying this, that 4x cubed plus 5x squared is equal to 9x to the 5. So let's substitute in 2, just for argument's sake, just to experiment and see if this would be true. So then I've written it there, I've substituted 2 in, and we get 32 plus 20, or 52, is equal to 288, which it clearly is not. So you can see that when we put an actual number in, or a number 4, when we substitute in 2 for x, this is false. And so we can't actually simplify it. So you've got to make sure you've got the same combination of letters, the same powers, and then you'll be able to add it or subtract it. When it's multiplication or division, you can combine anything. It doesn't matter whether they're different, the same, but we add our powers together when we're multiplying. So just looking at the first example before we go to the variables, the powers. 4 times g is 4g, 3a times 5b. We multiply the coefficients first, so 3 times 5 is 15, and then we just put the a and b together. If it was a squared, then it would still be a squared there. Just shove it together. When you are writing your answer, please just, the best format, and some teachers might mark you down for this, is you've got to first of all put your number, then you've got to put your letters alphabetically. And if you are organizing terms, like let's pretend that this second example was a plus, then you'd organize them in descending powers. So your highest power term first, moving down to your lowest power. Okay. So looking at this equation here, well, actually, it's only an equation because I solved it. We had 7a cubed times 6a squared times 3a. Now, again, this is one of those times when mathematicians agree that if it's a, it's a to the 1. So if you think of, if we were looking at powers of 2, 2 squared is 4, 2 to the 1 is 2, because it's 2, but it's only the 1 2. So we just don't write that 1 because it's, I suppose, redundant, a bit of a waste of space. But if we consider that it was 1, then it would be 3a, or 3 a's, 2 a's, and 1 a. So together, if we add those powers, 3, 2, and 1, we get 6. So then we multiply our numbers. 7 times 6 is 42, times 3 is 126. And then we put it together like that. It's useful to remember that something like c to the minus 1 actually means 1 over c. I can't see that your teachers would give you this, but if you do remember that, then you can actually subtract to the powers. So c to the 7 times c to the minus 3 is equal to c to the 4. So we simply subtract the 2 powers there. C to the minus 3 is the same as 1 over c cubed. So then we'd have c to the 7 on the top, c cubed at the bottom, and I've got a couple of examples of that on the whiteboard. We'll cancel those out and simplify. All right, I'm going to cross to the whiteboard now and just have a look at some examples. First of all, looking at some expressions and simplifying them, and then moving across and having a look at some equations and unraveling them and solving them for the variable. But I've got to just say that before I start, let's press on a little bit first. Okay, so looking at the first one, remembering that to add or subtract, well, maybe we should just look at how many terms this has first. We've got 1 term, 2 term, 3 terms, and 4 terms. So separated by plus and minus, those are our terms. We can only group like terms. Now, adding and subtracting, we have to have the same powers. So these two have the same powers. So b squared plus b squared is 2b squared. We have one b term with a single b in, so it's minus b, because remembering the sign comes with it. And then at the end, we've got a constant. So that is the simplification of those. We've grouped the like terms, we've put it together. Looking at the second one, we're going to start writing our answer by looking at the one with the highest power. We only have a single a squared. Again, this is one of those times when mathematicians are lazy. There is a 1 in front there. We kind of just go, well, what a waste of time to write that there's 1a when we've got 1a drawn there. So that is written as a squared, even though it means 1a squared, but it's the same thing. Grouping our a's together, we've got 2 a's. All right, a plus a is 2a. And finally, our constant at the end. All right. Then we're looking at our next example before we come to our division ones. So we've got minus 5 plus 2y squared plus 3 plus y. Looking at our highest power first, we've got 6y squared. Next, we have a single y. And finally, minus 5 plus 3 gives us, minus 2. All right, and that's our answer. We still don't know what y is equal to, but that's how we simplify the expression. Okay, then we get to ones like this with division. And I mentioned that this, in fact, this would be the same as writing, and I'll rub it out in a moment, a squared b divide, or in fact, we could even say times ab, I'm putting it in brackets, to the minus 1, which means 1 over ab. But we can also then write it as it's been written in this question. Okay, now when it comes to these, we look at each variable on its own. So I look at the a's first, and I go, well, I've got 2 a's at the top, because a squared is the same as writing a times a. All right, and I've got 1a at the bottom. Well, I'm going to cross out the one at the bottom, and one of my ones at the top, which leaves me with a single one at the top. I've got b's top and bottom. I've got 1 in each, so I'm going to cross those out. So in fact, all I'm left with is a over 1, which we just write as a. So that is our answer for that one. Looking at the example down here, I've written it differently now. So you seldom will get one that's written like this, but just if you do, you can rewrite it in the format where it's one fraction over another. So x, y, z over 3y squared z. Okay, so we'll start with looking at our numbers. We'll look at 12 divided by 3. How many 3's in 12? It's 4. Let me actually just write that up top for now. 4. Okay, I don't have any x's in the bottom, so that x is going to stick around. Y's, I've got 2 at the bottom, 1 at the top, so I'm going to cross out one of the ones at the bottom and 1 at the top. So I've got no y's at the top, but I've still got a y at the bottom. Z's cancel each other out, so I've got an answer of 4x over y, and that's my answer. All right, and before we move on to the slightly harder ones, simplifying algebraic expressions, these ones over here, I think it might be time for a Nomu hot chocolate study break. It really does make study breaks more pleasant. Let's be honest, studying sucks. But here at Worksheet Cloud, we make it suck way less. In Worksheet Cloud, you can earn avatars, sidekicks, collectible coins, and then level up all while studying. Plus, we've just added our most exciting feature to date, the brand new Worksheet Cloud Rewards Hub. With Worksheet Cloud Rewards Hub, you can earn epic rewards and unlock entry tickets to win real giveaway prizes, including a Sony PlayStation 5, some yummy Nomu hot chocolate, and some fresh Worksheet Cloud merch. The more questions you answer, the more points you earn, and the more rewards you unlock. Worksheet Cloud makes your studying easier with video lessons, practice exams, practice questions, and study notes. In other words, we're your go-to place for all your studying. Ask your parents to sign you up at worksheetcloud.com today. Okay, let's have a look. So when we're given situations like this, we need to start off by expanding the brackets. So I'm hoping that now you're comfortable with expanding the brackets, knowing that 4n on the outside, that means multiplied by the numbers inside, and we're first going to multiply those two, then we're going to multiply those two, then we multiply those, and then we multiply those. Okay, so minus times a minus is a plus. So we've got a positive term. 4 times 2 is 8. N squared minus, no, it becomes plus because the minus times a minus. 4 times 3 is 12, and 1n onto the second bracket. 2n times 1, or minus 2n times 1 is minus 2n. Minus 2n times minus 2n is plus 2n, so a positive times a negative is a negative. 2 times 2 is 4, n times n is n squared. Now that we've expanded, we can group. Our squareds are going to come first, so grouping 8 and minus 4, we are left with 4n squared. The n's come together, so we've got 12 minus 2 is 10n. And that's our answer. It's our simplified expression of that original expression. Okay, next one. Expanding first. 2x times 3x is 6x squared. 2x times minus 3 is minus 6x. Plus 7 times 1 is 7. 7 times x, 6x is 42x. We only have one term that is squared, so we're going to have 6x squared minus 6x plus 42 will leave us with plus 36x, and then we've got one constant plus 7. So there is our solution with that one. Next one. If you're comfortable with these, I suggest you actually just pause the video, practice them. If you get stuck, then turn the video on again. Otherwise, you can just check your answers when you've gone through them. One of the times, this is another one of those times when what you've learned in primary school is going to come back to help you. So, in the next question, I've got 7 times 8, and you shouldn't be spending time working that out. I know by now many of your teachers allow you to use calculators, but you really shouldn't be using calculators for that. You should just know that it's 56 without even thinking about it. In fact, when it comes to times tables, I'm not actually working things out because I've been working with them for so long. They're just like facts. So 9 times 8 is 72. That's just here. It's not me searching. It's just like a fact in my brain. But let's get back to this. 7 times 8 is 56. It's a negative because we got a negative and a positive. We got x squared. 56x squared plus 7x plus, because it's a negative times a positive. So in this case, we didn't write the 1, but it's the same as 1. So minus 1 times minus 2x is plus 2x. And the minus times a minus 3 is a plus 3. And we can get an answer then. We still got minus 56x squared. 7x plus 2x is 9x. And 3. Next question. All right, straight on to an answer. 3a squared plus a. 1 times a is 1a, but we don't write the 1. Plus 2a squared minus 5a. Squareds 3a plus 2a is 5a squared. A minus 5a is minus 4a. 2 more to go like this, and then we'll have a look at some equations. Right, okay, it's the next one that I put in some slightly bigger powers. So 2 times 3 is 6r squared minus 8r minus 5r squared plus 5r. Bringing that together, 6r squared minus 5r squared is 1r squared, or just r squared. Minus 8 plus 5 gives me 3r. Last one. I've just added an extra power in just to make it a little bit bigger, but it's going to work exactly the same. 12r to the 3, so 2 r's and an r makes 3 r's. And then minus 20r squared minus 12r cubed plus 20r squared. R cubed together, so 12 minus 12, those cancel each other out and there's nothing left. 20 and minus 20. Answer is 0. Does happen. Okay. I haven't done quite as many of the algebraic equations. I think what I want you to take away from the algebraic equations is this is like, I suppose, unraveling a knot. You've got to take what's been put in here and you've got to unravel it until you can find out what is just 1x. So we work backwards from what we've got. So step 1 is we've always got to try and isolate our variable. So we want to get our variable on our own. So our variable is 10x. Or our term with the variable in is 10x. So if I say, well, I want to get rid of 5, so it's a positive 5. What's the opposite of positive 5? Negative 5. So I'm going to subtract 5 from that side. But the thing about an equation is if you want it to stay an equation, you have to do this, as in both sides are equal. You have to do the same to each side. So what you do to the left, you do to the right. What you do to the right, you do to the left. Sorry, I also teach primary school and songs stick in people's heads, even high school students. Okay, so if I'm going to subtract 5 from that side, I'm also going to subtract 5 from that side. What that means is on this side, I will be left with just 10x or plus 10x. And on this side, minus 15 minus 5 gives me minus 20. The next step is that I don't want to have 10 x's. I want to know what 1x is worth. So this means 10 times x. The opposite of the opposite of times is divide. So I would divide that side by 10, and what you do to the left, you do to the right. Divide by 10, which will leave me with, well, I'm running out of space, should have done it smaller. The two 10s will cancel. Sorry, I'm just squeezing it in here. So I'm left with an x on that side. 10 goes into there twice, 10 goes into there once. We still got a minus, so x is equal to minus 2. All right, and if you're a good mathematician, you should go back to your question and check. So what we've got over here is if we put in minus 2, 10 times minus 2 is minus 20. So 5 plus minus 20, which is minus 20, is minus 15. So it is true, it's correct. All right, good to go back and check. Okay, let's look at the next one. This is a little bit more complicated because we've got this little division thing in. There are different ways to do this, but I would again advise that you always isolate the term with the variable in. So this is the one I want to get on its own. Now it doesn't matter which side it goes because this equals this equals this. It means the same backwards or forwards. Some teachers might want you to write the variable equals a number like x equals 5 or x equals, but I don't mind. I say you can say 3 equals x or x equals 3. It's the same thing. All right, so I kind of want to get rid of that one. Now that's minus 3, so I'm going to have to add 3 if I want to get rid of that. So I'm going to add 3 to that side, have to add 3 to that side. Now, I'm trying to make my thinking visible over here. But this I would typically do in my head at a grade 9 level. But if you're unsure, I'll always advise you to write down your workings. And in fact, the other thing I advise you to do is if you do any workings on the side of your page, don't erase them. Do them neatly and also number them so your teacher is able to see which workings go with which problem that you're solving. And the reason I advise children to do that is that if I'm a teacher and I'm looking at work and the child's got the wrong answer, all I can do is write is put a cross or put a dot, whatever it is. I've got to say it's wrong. But if I can see their working and their processing, I can figure out what is it that they're making a mistake with. Because often, as you learn it, you tend to make the same mistake over and over again. And if you just correct the mistake, then suddenly you go from getting everything wrong to everything right. And it's just one aspect of the problem that you keep getting wrong. So don't rub out your workings. Teachers like to see them. Unless you have a weird teacher who tells you to rub them out. But I don't think you would. Bad teacher. No, don't tell your teacher I said they were a bad teacher. Okay, we're left with, that was a long way to do it, 6 equals, those two cancel each other, x over 4. Now, x over 4 means x divided by 4. The opposite of division is multiplication. So if I multiplied this side by 4, I would then get just x. And then I multiply this side by 4, and I get 24. So x is equal to 24. Next question. Let's choose different colors this time. I don't have such a wide variety. Let's go with blue. All right, so similar style here. I want to get rid of the -5, so I'm going to make +5, +5. -2 plus 5 is 3, equals x over 8. Multiply both sides by 8 to get rid of the 8 at the bottom. I'm left with an x on this side, and 3 times 8 is 24. X equals 24. Did I write the same problem twice? No, just happened to be the same answer. All right, next we're going to have to multiply this out. So we start off by going 2x squared plus 10x plus 3, is equal to 3x minus 3 plus 2x squared minus 4. All right, now it may look complicated because we've got the squareds and the other things there. But what I want to notice now, and it doesn't matter which side you're going to go, but I'm going to move, let me zoom in a little bit. I'm going to move the x squareds across to that side. So to move or to get rid of this x squared on the right, I'm going to subtract x squared. And if I do it on that side, I'm going to do it on that side too. Now, as it so happens, that means that both x squareds are going to cancel out. So once I've moved them to the left, there is no x squared term left. So I'm now only left with x's and constants. All right, let's neaten things up a bit. I've got 10x plus 3 is equal to 3x, and let's put my constants together, minus 7. So minus 3 minus 4 minus 7. I'm going to move my x's to the left and my constants to the right. So the opposite of 3 is minus 3. I'm going to minus 3 on that side as well. And the opposite of 3x is minus 3x. And I'm going to minus 3x on that side as well. Which leaves me at the end of all of that with 7x is equal to minus 10. Right, now in this case, we are then going to go, well, I'm going to divide both sides by 7 because I've got 7 x's and I only want 1. So 1x then, because the 7's will cancel out, is equal to minus 10 over 7. And I think most teachers will be happy if you leave it in this form, or if you simplify it to a mixed number, a mixed fraction, so minus 1 and 3 over 7, but they won't expect you to put it into decimals. So please careful if you do work it out on a calculator that you don't put your answer as decimals unless requested. Reverse engineering when it comes to squareds. The opposite of a squared is a square root. That should be familiar now, but let's do it. So we want to get rid of this 21, or we want to move it across to the other side. I'm going to minus 21 minus 21. t squared is equal to 9. Right, the opposite of this is a square root. I must square root both sides. What I'm left with is 1t is equal to 3. It is important to start recognizing squares for one of the lessons that's coming up about factorizing the difference of two squares. Okay, a couple more to go. Start with this one. Should be quite straightforward. Q squared, and add 14, add 14. Q squared is equal to 4. Take the square root of both sides. Q is equal to 2. Next question. Now this is a bit of a weird one. I don't know where I got this one, but there we go. Is why do we even have this bracket? Now you can multiply the bracket out and you can say y squared, 5y squared minus 2y squared, and you get 3y squared. But you could just say, well, that's 3. So this side is 3y squared and that side's 27. I want to get rid of the 3, so I'm going to divide both sides by 3. That will leave me with y squared is equal to 9. Take root of both sides. Y is equal to 3. All right, final one for today. We're going to wrap up, and then next time we're going to go on to factorizing or common factors with algebra. I'm taking those out and simplifying. But let's take a look here. All right, we're going to start off by multiplying out. So 4p squared plus 2. No, 2. There. 2 times 9 is 18. Whoa, why would I do that? Surely I can just say 2 plus 9 is 11. 11 times 2 is 22. 22p squared equals 198. I worked this out before. P squared, because we're going to divide both sides by 22. What was it? It was 9, wasn't it? Yeah. P squared is equal to 9. Quickly going to check that. Bear with me. Can't handle making a mistake. 198. It is 9. I was right. Okay, and then we take the square root of both sides, and p is equal to 3. You won't always be given nice numbers. You might sometimes be given a number that would be ending up as, you may have a situation where your answer is x is equal to root 10. Now, root 10 is not a pretty number. It's got lots of decimals. In fact, it's a repeating decimal. And in that case, you just leave your answer in third form. So you just leave it like this. That's the answer. You're not normally expected to actually calculate the answer. In fact, a lot of maths, once you get to high school, is really about your teachers just want to see that you're able to figure out the problem. They're often not really all that interested in the answer. It doesn't matter. Okay, that's all very well and good. But watching somebody do maths is not the same as doing maths. And with that in mind, I just want to expand that to you don't learn how to do something by watching. It might help, but it's not going to make you good at something. And practically, if watching cricket made you a good cricketer or watching tennis made you a good tennis player, I'd be really good at both of those. But sadly not. So once you've finished the video, check below in the description, click on that link that's there. It'll download a free worksheet from Worksheet Cloud, which you can then practice what it is that we've been looking at in this lesson. And hopefully that'll cement it in your brain and you won't have any issues with this kind of thing in the future. Finally, if you are not already signed up to Worksheet Cloud, send your parents across to worksheetcloud.com so they can sign you up so you can access all the resources in all the subjects and get great marks at school, as well as, and I'm sure you're not so excited about this, is all the extra work that you could be doing at school. But, it also does give you access to that rewards page where you can earn Nomu hot chocolate, merchandise from Worksheet Cloud, or possibly even that PlayStation 5. I have a feeling it's going to be the grade 9s that win it. Anyway, chat to you soon. Bye.